This lesson is direct variation. The goal is to write and interpret direct variation equations. What you should understand by the end of this lesson is that some quantities are in a relationship where the ratio of corresponding values is constant, and that you can write a direct variation into a function. Remember, a ratio is nothing more than a fraction. Now, the formula for direct variation is y equals kx, or y over x is k, where k does not equal 0. And k is what we call a constant, or a constant of variation. It just means it changes by that amount every single time. So x represents the inputs, y represents the outputs, and the formula y over x equals k says that except for 0, 0, the ratio of all the output-input pairs equals k, the constant of variation. And all that's saying is that for every time that x changes, y changes that certain amount. If x changes 2, y changes that amount. If it changes 4, that amount changes, y changes that amount. And we're going to take a look at how that works. Now, this is how you can tell whether or not a function, whether or not y varies directly with x. We're going to make a ratio, we're going to make a fraction, and we're going to put y over x, make a fraction, reduce it, and see if it's the same every single time. So we're going to start with A, the one on the left, and we're going to put y over x. So I've got 2 over 1, which is 2, and then 6 divided by 3, which is 2, and 8 divided by 4, which is also 2. So, yes, that is a function, and our constant of variation is 2. That means every time I take x and multiply it times 2, I get y. All right, so let's look at B. I'm going to take the y and put it over x. So I have 4 over 1, that's 4, and 8 over 2 is 4, and 11 over 3 is not 4, so no, that is not, y does not vary directly with x. And that's how you tell whether or not it is a direct variation. All right, here's the kind of problems you're going to see. In a direct variation, y equals 16 when x equals 4. So we're going to write a direct variation equation once we find out what the constant is. So I take 16 divided by 4. My constant is 4. So here's my equation. Y equals 4x. And there's my equation. So again, that's my y, that's my x. All right, here's one with fractions. I'm going to do my y over my x, find the relationship, and write an equation. So 1/2 divided by 9/2. Well, when you divide by a fraction, you invert the second and multiply. So I'm going to have 1/2 times 2 over 9ths. These cancel out, so I have 1 over 9. That's my constant. So my equation is y equals 1/9 x. And of course you can put this into your calculator to multiply or to divide your fractions, and then you would put it in as 1/2 divided by 9/2. It would show 1/9, and you still get the same answer. Here's your practice problem. In a direct variation, y equals negative 50 when x equals 10. Write a direct variation equation that shows this relationship. Practice 2. In a direct variation, y equals negative 19 when x equals 9.5. Write a direct variation equationship that shows the relationship. Alright, here's a little different type of problem. It says if y varies directly with x and y equals 18 when x equals 9, find y when x equals 5. So we're going to take y over x, so 18 divided by 9. 18 divided by 9 is 2. That's our constant. So our equation is y equals 2x. They want to know what the equation is when x is 5. So y equals 2 times 5. And 2 times 5 is 10. So when x is 5, y is 10. Practice 3. Assume that y varies directly with x. If y equals negative 16 when x equals negative 4, find y when x equals 3. Again, this changes it a little differently. If y varies directly with x and y equals negative 15 when x equals 3, find x when y equals negative 5. So again, I need to find my constant. So I'm going to take negative 15 divided by 3, and find out my constant of variation is negative 5. My equation is y equals negative 5x. They want us to find x when y, so I have y, so negative 5 equals negative 5x. So I just divide both sides by negative 5. I get 1. So when y is negative 5, x is 1. Practice problem 4. If y varies directly with x and y equals negative 20 when x equals 5, find x when y equals negative 16. The final kind of problem that you'll see is when you're given a direct variation and they give you 2 points. In this case, we're given the points 5, negative 10, and negative 2n. And they want us to find n, or they want us to find the y value on the second point. So what we need to do is make a proportion. Remember, we're going to put the y value over the x, and we're going to do that in both fractions. So I'm going to start with the first point. My y is negative 10, my x is 5. On the other one, my y is n, my x is negative 2. Now, if you remember, when you solve equations, or when you solve proportions, sometimes you hear it as bat and ball, or you'll hear it as cross multiply and divide. Either way, I will multiply negative 10 times negative 2, and I get 20. Then I divide that by 5 and get 4. So n equals 4. And that's how you solve that one. All right, here's your practice 5. Here's a direct variation, and it includes the points 2, -8, and n, 4. Find n. Practice 6. A direct variation includes the points 9/2, -1/2, and n, -1/6. Find n. Use your calculator, multiply your fractions, divide by the third one, and find n. All right, now that you've went through this lesson, done the 6 practice problems, you need to show them to me. Once you've done them correctly, mark on your goal sheet how you are or where you are on the scale of understanding. Are you at a 1, 2, 3, or 4? Go do your lesson in IXL. Make a 90 or better. And that's all for this lesson. Bye.